Hi everyone, so this is a video on chapter 2.5 of the Year 2 Pure book, and in this chapter we're going to be looking at graphs of y equals the modulus of f of x and y equals f of the modulus of x. So we've just got a generic function here. This is y equals f of x. I'm just going to label some points of intersection with the axes. So do that before. So we're just going to write down the steps to draw these two different graphs. So to draw the graph of y equals the modulus of f of x. We follow two steps, or three steps actually. So the first step is that we would initially sketch the graph. Sketch the graph of y equals f of x, which we already have here. Next is that we reflect any parts where the function, so where f of x is less than 0, and these are the parts that are below the x-axis. So that's where y is negative, essentially. Parts below the x-axis in the x-axis. So we reflect any parts that are below the x-axis in the x-axis. Because if we want to, remember the modulus is the kind of non-negative value of something. So any negative values of this function need to be made positive. So anything below the x-axis where y is negative needs to be made positive. So that's why we reflect in the x-axis any parts that lie below the x-axis. And then lastly is we would delete any parts below. Below the x-axis. So I've already got my sketch of f of x here. So beneath them, on a new set of axes, I'm going to draw, for this particular function, I'm going to draw y equals the modulus of f of x. So from the beginning of my function here, I can see that I'm above the x-axis and y is positive, so that's absolutely fine, so I can continue with that. Then I hit this intersection point of 3. I'll just draw my other ones in quickly. And then this part starts to dip below the, this part here is below the x-axis, isn't it? And remember, any parts below the x-axis need to be reflected. Because we're doing the modulus of f of x, everything has to be positive. So this point of intersection, -6, is actually going to move up to 6 there. And the part that kind of curves below the x-axis is going to now curve above the x-axis. This part of the graph is already above the x-axis, so that will stay there. And then this part here that starts to dip below the x-axis, again will be reflected above, so it will go up to here. So this is the graph of y equals the modulus of f of x. Then the next graph, so maybe I'll do that down, I'll just do it here. So to draw the graph of y equals f of the modulus of x. Lots of lines and brackets when writing these things. So we're going to follow two steps here. So actually, before we write the steps down, we can think about what this shows. So this time we have the modulus of x. So any negative x values are going to be made positive. They have to, because we can't have any negative values of x. So what we would do is we would sketch, not that one, sketch the graph of y equals f of x for x is greater than or equal to 0. So we draw the part of the graph that is, we draw the part of the graph for all positive x values, and then we would reflect this in the y-axis. So just to see what that looks like for our original function up here, f of x. Move my page up a tiny bit. So on a new set of axes, I'm going to draw y equals the modulus of f of x. So for my original function f of x, I'm going to draw the part of the graph, part of f of x, that is for all x is greater than or equal to 0. So it's all of this part of the graph. So I'm down here at -6, and I'm passing through 3 there. So this is my part of the graph for x is greater than or equal to 0, and then I reflect that in the y-axis. So I'm no longer going to have this part of the graph, I'm just going to have a reflection of this part, which will obviously intersect over here at -3. So this is the graph of y equals f of the modulus of x. So we'll do examples 17, 18 and 19 now. Just make those notes. Okay, so example 17. So example 17 gives us f of x is equal to x squared minus 3x minus 10. And part A, B and C is to sketch f of x, sketch the modulus of f of x, and sketch y equals f of the modulus of x. So I'm first just going to think about, well, for part A where I need to sketch y equals f of x, I need to know my intersection points, don't I? So I'm just going to factorise this expression so I can find out my my intersection points with the axes. So this factorises to x is -5, x minus 5, x plus 2, which gives us intersection points of 5 and -2. And then my y-intercept is going to be -10 here. So I'm just going to draw myself a set of axes. Remember, this is just a sketch, so labelling all the intersection points with the general shape of the graph is all that's necessary. So this is a quadratic that passes through -10, and it will pass through x is 5 and -2. So y equals f of x is going to look something like this. Okay. Now for part B, we can go on to sketch the modulus of f of x. Y equals the modulus of f of x. So if we follow our steps from before, we first need to sketch y equals f of x, which we've got here, so I'm not going to do it again on these axes, although you could with a pencil. If you wanted to. In fact, I don't have a rubber, so I'm not going to rub it out. But it would be a good idea to do that. Draw it in pencil and then reflect it and then rub out below the x-axis, but I don't have a pencil, so I can't do that. And we need to reflect any parts where f of x is smaller than 0, so anything below the x-axis, we need to reflect that in the x-axis. So we're still going to have all the same intersection points here. 5, well, on the x-axis anyway, -2, but this part of the graph is going to be reflected up, isn't it? So this intersection point is going to jump up to 10 there. So we're going to be coming down like that. And instead of dipping below, we're going to go above, and then this part of the graph carries on as normal up here. So this is the graph of y is the modulus of f of x. All negative y values have been made non-negative. And then part C, I'm going to draw y equals f of the modulus of x. So another set of axes for us. And remember, the steps here are that we sketch the graph of y equals f of x for x is greater than 0. So I'm going to sketch this part here where all the x values are positive. So we're going to have intersection point at 5, and at negative 10 we're going to touch the axis. I've probably drawn that there. So we kind of went like this, didn't we? And then that gets reflected in the y-axis. So this intersection point, I'm going to have one over here as well, and that shape is going to be reflected like that. So this is the graph of y equals f of the modulus of x. So quite okay, really, isn't it? So example 18 is more of the same as this, with a different function. So in example 18, we've been given g of x, and g of x equals sine x. And this is for x values ranging from negative 360 to 360. So part A, we'll sketch the graph of y equals g of x. So give myself a nice long set of axes there. Whenever I draw the sine graphs, I always like to draw kind of like 180 and 360 to help me get it nice and symmetrical. So this would be 360 up here, and this would be negative 360. So, and we know that our sine graph ranges between 1 and negative 1. So, sine graph starts off like this, and then there we go. So that's our y equals g of x. And part B wants us to draw y equals the modulus of g of x. So a new set of axes. So, remember the steps. We have our graph of y equals g of x, and we're going to reflect any parts that are below the x-axis in the x-axis. So we're still going to be ranging, well, we're still going to be going up to 1, but I mean, we can label negative 1 if we want, but we're not going to have any parts of this graph below the x-axis, are we? Everything is going to be above the x-axis now. So, our sine graph starts off here. That's absolutely fine because that's above the x-axis, and then this part below the x-axis needs to be reflected, so it's going to look like that, and that's up to 360, and then the same for this, for where x is less than 0, we have this part here which has been reflected, and then this part here stays the same. A little bit too high for that one, and a bit too pointy as well. But you get the general gist of what I'm trying to achieve. And then part C is to draw the graph of y equals g of the modulus of x. So part C. So, to draw y equals g of the modulus of x, we're going to sketch the part of the graph. So sketch the function for x is greater than 0. So this part of the function is exactly the same as g of x. And then that needs to be reflected in the y-axis. So we end up with this function here. And this is y equals g of the modulus of x. Okay, and then example 19. We've got a diagram given on the page, and so the diagram shows the graph of y equals h of x with 5 points labelled. Sketch each of the following graphs labelling the corresponding points. So part A wants us to sketch y equals the modulus of h of x. I'm going to draw myself a nice big set of axes, and obviously whilst I do this you will need to refer to your textbook so that you can see what this function looks like. When I talk about point A, B, whatever, you kind of know what I'm talking about. So draw myself a nice big set of axes. It's quite a large function with different kind of curves in different places. Okay, so to sketch y equals the modulus of h of x, remember everything below the x-axis needs to be reflected in the x-axis. So if I start with this part of the graph, you can see, if you look at your textbook, this part of the graph kind of curves beneath and then kind of reaches up to the x-axis at point D, which has x coordinate 3. It then starts to reach up to the y-axis at point C, which is 11. So that whole part below the x-axis, so between point D and onwards, needs to be reflected, doesn't it? So that means we're going to be kind of flattens, it's kind of flat here, goes up to a peak and then moves down like that towards D. Now point E, which was below the x-axis, has been reflected. And when you reflect a point, when you are doing these sketches, we would call this E dash. We're not going to call it something else, a different letter, we call it E dash. It's point E but reflected, and its coordinates are going to be 6, 5 rather than 6, -5. Point D is still going to be point D. We're not going to call that D dash because it hasn't actually moved, or it's not been reflected anywhere. Point D is kind of an acceptable point for this function. This graph then goes up towards point C here, and point C is above the x-axis, so we're allowed to keep that. And also point B is as well, so point B is the kind of peak of this next the next part of the graph, which has coordinates -2.5, 15. And then our graph goes up through through C, through B, and then back down towards the x-axis at A, which has an x coordinate -7. So our graph moves up like this. It then does start to dip below the x-axis, which I'm going to make sure I don't draw. So this is our function y equals the modulus of h of x. Part B wants us to draw y equals h of the modulus of x. So continue on the page. Point B. So when sketching the function y equals the modulus of f of x, remember we draw the function for x greater than 0 and then we reflect it in the y-axis. So this function, for x is greater than 0, we have point C, which is at 11. We have point D, which is at 3, x equals 3. And then we have point E down here. So all of this stuff that's for, all of this part of the function for x is greater than 0, we're keeping. That was point E. So our graph goes a little bit like this, and then kind of tails off like that. Now this needs to be reflected in the x-axis. In the y-axis. So we're going to have a reflected point D dash here at -3. So this is going to be D dash, and we're going to have a reflected point E dash as well. Which is at -6, -5. And we're going to copy in the shape of this graph, so we're going to go down through E and then tailing off. Not the best sketch, but all of my points are in the right places and they're all labelled correctly. So that is the graph of y equals h of the modulus of x. And that is literally it. So these examples should help you get through the chapter questions here for exercise 2E.